Hi everyone, today we're going to be talking about the idea of characteristics of quadratic functions. So go ahead and follow along with your notes. If you have any questions, please let me know. Quadratic functions, like linear functions, have a few key characteristics, basically things that make them quadratic functions. Quadratic functions take the shape of a parabola. That's probably one of the most important things about quadratic functions, meaning that they either make this type of U-shape or a U-shape that's facing down. In a future math class, you might learn about quadratic functions that are going to the left and to the right, but we're not going to worry about those during Algebra 1. Okay, so the characteristics of a parabola, or some of the key characteristics are, one of them is x-intercepts. So if you're looking at this graph over here, the x-intercepts are the spots where the parabola, where the function crosses the x-axis. So in this case, it would be negative 1, comma 0, and 3, comma 0. The next characteristic, very similar to a linear function, would be a y-intercept. So you would look along the y-axis, and the point where the parabola crosses y-axis is right here at negative 3. So that would be 0, negative 3. Now what's interesting about parabolas is the fact that they actually curve. So because they curve, they have something called a vertex. That vertex is essentially the turning point of the parabola. If you're going from left to right, the parabola is going down, and then at this point it starts to go back up. So in this case, the vertex would be at 1, negative 4. So that's 1, comma, negative 4. And then finally, there's something called the axis of symmetry. The axis of symmetry is kind of the imaginary line that would cut the parabola right in half. And in this case, because it's at where x equals 1, then the axis of symmetry is x equals 1. Okay? So in this lesson, what's going to be super important is for us to understand the terminology and the vocabulary. So make sure that you save this set of notes so you can continue referring back to it throughout the entire unit. So, x-intercepts are where the function intersects the x-axis. X-intercepts can also be called roots, solutions, or zeros. So that's kind of what's interesting about x-intercepts, is that these four words actually all mean the same thing. X-intercepts, roots, solutions, or zeros all mean the same thing. Okay. The next characteristic was the y-intercept. The y-intercept, just like in a line, is where the function intersects the y-axis. Now the new, kind of a newer word that we're talking about here is the vertex. The vertex is where the parabola has a turning point. This could be a maximum, which would be like the highest point of a parabola. Like if you had a parabola like this, and then it was the highest point. Or it could be a minimum, meaning a parabola that was facing up like this, and then it had a really low point. Alright? And then the other kind of new terminology that we're using is the axis of symmetry. The axis of symmetry is the line that indicates the midpoint, which is basically just halfway of the parabola. So if you have a parabola like this, then the axis of symmetry is the imaginary line that would split it exactly in half. Okay? So let's see some examples so we can practically understand what this means on a graph and on a table. And before that, if you want to pause the video and try for yourself identifying the x-intercepts, y-intercepts, or the vertex of each of these quadratic functions, you can try and do that. So here's the first example. So what we're going to do is we're just going to start to basically understand if we have a table of values and we plot it. One, how do we know from that table that the function is quadratic? But then also, how do we label some of these key characteristics of x-intercepts, y-intercepts, vertex, axis of symmetry based on the graph? Okay, so let's go ahead and plot these. -3, 12. That means I go to the left 3, up 12. That's going to get me off the graph somewhere here. -2, left 2, up 5. -1, 0. I just go to the left 1 space. 0, -3. That's just straight down 3 spaces. 1, -4. That's to the right 1 space and down 4. 2, -3. That's to the right 2 and down 3. 3, 0. That's just to the right 3 spaces. And then finally 4, 5. That's to the right 4 and up 5 spaces. So you'll notice that when you plot the points, and if you outline them from left to right, just like you read, that it makes the shape of a parabola. Okay? So the other thing that you want to notice here is that if you were just given the table, there's a way for you to determine if it's quadratic, right? So from 12 to 5, the rate of change is -7. From 5 to 0 is -5. 0 to -3 is -3. -3 to -4 is -1. -4 to -3 is adding 1. -3 to 0 is adding 3. And 0 to 5 is adding 5. So in linear functions, that first rate of change has to be all the same. But in quadratic functions, it's the second rate of change that has to be all the same. So let's check the second rate of change. From -7 to -5, you're adding 2. -5 to -3, you're adding 2. -3 to -1, you're adding 2. -1 to +1, you add 2. 1 to 3, you add 2. And 3 to 5, you add 2. So when all of these are the same, when that second difference is the same, we know the function is quadratic. So now that we know it's quadratic, we can try and look at some of these key characteristics. So if we look at the x-intercepts, we look at the parabola and see where it crosses the x-axis. So I notice it crosses the x-axis here, and it crosses the x-axis here. That left point is -1, 0, and the right point is 3 spaces over, so that is +3, 0. Now I look at the y-intercept. So for the y-intercept, I look at the y-axis, and I just go up and down the y-axis and see where the parabola crosses. I notice that it crosses right here, which is 3 spaces down from 0, 0. So that means it's 0, -3. Notice how for the y-intercept, because the second number is always y, that's where I put the number, not the 0. And for x-intercepts, the number goes right here. Now the newer aspect that we're talking about is the vertex. So if I'm looking at the parabola and where it changes direction, if I'm moving from left to right, I notice it's going down, down, and then at some point, the vertex, it starts to go back up. So the vertex is actually right here, which is at +1, -4. So that's my vertex. And then finally, my axis of symmetry is going to be actually right where the vertex is. It's going to be the straight line up and down. That's right where the vertex is. So because it lands on x = 1, that's what the axis of symmetry is. Okay, let's move on to the next example. So in looking at the second example, this one's going to be slightly different because we're actually going to need to extend the pattern to be able to see all of the x-intercepts, y-intercept, vertex, and axis of symmetry. So if I look at -2, -8, let me start by plotting these. I go to the left 2 spaces and then down 8 spaces. -1, -9, that's to the left 1 space and down 9 spaces. 0, -8, that's just straight down 8 spaces. 1, -5, that means I go to the right 1 space and then down 5. And then 2, 0, that just means that I go to the right 2 spaces. So what this means is that if I connected the dots from left to right, that I have the beginnings of a parabola. So what I also notice here is that I actually already see some of these things. Alright? So now what I imagine is going to happen with this side of the parabola is that this is actually going to go back up. Alright? But before we do that, let's actually see what we already know. So if we look at the x-intercept, we notice there is at least one x-intercept right here. And that's at 2, 0. We may have another one, especially if this does end up going back up here. Okay? The y-intercept, if I look at the y-axis, ends up being right here, which is at 0, -8. Notice how some of these points are actually exactly in our table. Now the vertex is kind of interesting because how we know that this is the beginning of a parabola is that if you do go from left to right, there is a point already where it goes from going down to going up. And that point is this one right here. So that is our vertex, and that's going to be at -1, -9. And along with that, because we know where the vertex is, that means that we know the halfway point, the axis of symmetry, must be right here. And that's x is equal to -1. Notice that the axis of symmetry is always going to be the x value of the vertex. So if the axis of symmetry is 2, then the vertex will have a 2 first. If the axis of symmetry is 3, then the vertex will have a 3 as the first number. Okay? So we actually need to continue this parabola to be able to find some other pieces here. Because if we know that this parabola is going to go back up like this, that means that it actually does cross the x-axis again. And we need to find out where that is. Okay? So how we can find out where that is we can find the halfway point, right? So the axis of symmetry is our halfway point. So if my halfway point is at -1, and I already know that one of the x-intercepts is at +2, then I just need to count the spaces between those two. So I have 1, 2, 3 spaces. So to find the other x-intercept, I just need to go in the other direction. So 1, 2, 3 spaces. So what this means is that I'm actually going to also have an x-intercept at -4, 0. With the x-intercepts, the y-intercept, and the vertex, and the axis of symmetry, I'm able to draw at least a rough idea of what this parabola is going to look like on the left side. If you want to erase some of this stuff in the middle so that you can really see the parabola, that's up to you. Okay, let's look at the third example. In the third example, we're going to have a similar situation where we're going to need to find if there is another x-intercept or not. Okay, so let's start plotting these. 0, 9, that's straight up 9. 1, 4, that's to the right 1 and then up 4 spaces. 2, 1, that's to the right 2, up 1 space. 3, 0, that's to the right 3, and I don't move up or down. And then finally 4, 1 is to the right 4 and up 1. So now if I connect the dots, I see the beginnings of a parabola. Again, the way that you can make sure that this is going to be a quadratic function is you can check the differences. So from 9 to 4, that's subtracting 5. 4 to 1, that subtracts 3. 1 to 0, that subtracts 1. And 0 to 1, that adds 1. And then if I check the second difference, from negative 5 to negative 3 is adding 2. Negative 3 to negative 1 is adding 2. And negative 1 to positive 1 is adding 2. Since all of the second differences are the same, I know it's quadratic. You can also do that on example 2, and you would be able to find that. Okay? Now at this point, I want to see any x-intercepts that I have. So when I check the parabola, I notice that it does have one x-intercept. And that x-intercept is right here at 3, 0. Now if I were to actually finish this, right, if I know the shape of a parabola looks like a U, then I know that this is going to have to go back up here. So if it goes back up, that means it's actually not going to cross the x-axis again, because it actually hit the x-axis only once. So let's check for a y-intercept. Y-intercept, I check my y-axis, and I notice I do have a y-intercept that's right here. And that's going to be at 0, 9. Now I want to check for my vertex. So again, my vertex is my turning point. So if I'm reading from left to right, I go from left to right. This is going down, down, down. And then at this point right here starts to go back up. So this point is 3, 0. Notice how in this case, the x-intercept and the vertex are exactly the same thing. And then finally, if I want to find that halfway point of the parabola, it's going to be right on the vertex, the straight line that goes, the straight vertical line that goes right through the vertex, which is at x equals 3. Remember, this is going to be exactly like your vertex. And in this case, because the vertex is the same as the x-intercept, it's also the same as the x value of the x-intercept. Okay, let me know if you have any questions, and that's our video for today.